different polygons on the coordinate plane. There are several ways that you can go about finding this. You could either use the distance formula, which is what we're going to focus on in this specific video, or you could use the Pythagorean theorem, which will come at a later time. But before we even go about how to actually calculate that, let's make sure that we understand what is perimeter and what is area. Perimeter is the distance around a figure. So if you think about this rectangle as like a fence around a building, the perimeter would be the length from the very beginning of the fence all the way back around to the beginning point. So you would add up the sides. In this case, the fence would be 8 units because 3 plus 3 plus 1 plus 1 gives you 8. The area, on the other hand, is the space that's covered within that two-dimensional figure. So if we think of the same fence, the area would be all of that space that's within. And there are so many different ways you could find area. It depends on the polygon, but we're going to focus on a triangle and a rectangle. A rectangle, the area for that stems from the formula base times height, because it's essentially all of the numbers and the values that are within this. You'll see an example of why exactly it is base times height in a second. And the reason that there's a diagonal drawn through this is just to show you the relationship between a rectangle and a triangle. A triangle is half the size of a rectangle, which is why in the formula it's being divided by 2. Same formula, but divided by 2. Or you could see it as area is 1/2 your base times your height. So these are things that hopefully you know by now, but want to make sure that you feel comfortable with the background information. So let's apply this to a couple of examples on how to find the area and perimeter first of a rectangle. So recall that perimeter is the distance around a figure. So to find the perimeter, we need to know what all of these sides are. It's not given, but we can count. Anytime you have a horizontal and a vertical line, just count them. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units. And because this is a rectangle, we know this is 10 as well. You can count it if you don't believe me. And we'll do the same thing for the side. So 1, 2, 3, 4, 5. That's 5 and that's 5. So to find the perimeter, you would add all your sides. So we have 10 plus 10, 2 of them, plus 5 plus 5. And that's going to give you 30 units. And that would be the perimeter of your rectangle. All right, now the area. So the way that you can find area, hopefully you remember the formula is base times height. If you wanted to take the super long way, just go ahead and count all these boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have time for that. So let's just use our values. If you count this, you'll find that you'll get the same answer we're about to get. The base is like the bottom. The bottom is 10. So it'd be 10 times our height, which is 5. 10 times 5 is 50. And this is square units. So if you were to count all those boxes, you would actually see that we got 50, which is why we can use this formula, because it gives us the same values. Now let's look at a triangle. So in this triangle, we want to do the same thing. We want to figure out what the perimeter and the area is. And remember, we can count our sides if they're horizontal or vertical. If they're diagonal, we're going to have to do some work. So I see a vertical line right here. So I'm just going to start by writing BC, because that's the line segment, and let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units. Now what we want to do is we want to figure out how long AB and AC are. Unfortunately, because they're diagonal, we can't just count them because each of these has a different length, because it's not a full 1 unit. It's going to be some type of decimal. So as opposed to approximating, what we do is we use the distance formula, and that should give us what we need. So this is the distance formula right here. And the way that you use it is you need to know the points. So we have our points here and here. And we subtract the x values and the y values and do a couple of other things to get the actual number that we need to use. So let's do an example here. I'm going to use a thin pen because it's going to be a little bit of writing. All right, so AC, let's actually say AB, because we're going to use red. All right, so let's focus on AB, which is this red line. So we're going to use this point and this point because these are the 2 points that define this line. So in order to do that, what we want to do is subtract our x values. So x2, so 4 minus a negative 5. And we're going to square that. And that plus our y value, so 6 minus 4 squared. So if you remember, 2 negatives make a positive. And let's keep going. Okay, so 4 plus 5 gives us 9, so we have 9 squared. 6 minus 4 gives us 2, so we have 2 squared. And then let's evaluate what that is. So 9 squared is 81. So this is 81 plus 4, which hopefully we know is 85. So I'm going to figure out what the square root of 85 is. And what I use is this calculator called Desmos. So it's desmos.com/calculator. You should have seen it in your quizzes already. If you type the square root of 85, so what that is, or where it's located, is you go to the keypad and then press the square root symbol and then type 85. This is your answer. So we'll round to the nearest hundredth. So the 9 is going to bump that up to a 2. So it would be 9.22. And that's the length of this line right here. So 9.22. All right, so let's do this one more time because we have another diagonal. So we're going to use this time this point because that's what defines A, and then this point because that's what defines C. So this is for line segment AC. All right, I'm going to write a little tinier. All right, so our two x values are 4 and -5. So 4 minus -5, same thing as before. And then we're going to use our y's. So -3 minus 4 squared. All right, so let's start to simplify this. So remember, two negatives create a positive in this case. So again, that's going to give us 9. So 9 squared plus -3 minus 4 is -7 squared. All right, so this will give us 81 plus -7 squared gives us 49. And let's see what that is. So coming back to Desmos, and I'll open up another tab. So we're doing the square root of 81 plus 49, which is going to give us 11.40. And kind of going backwards, but 81 plus 49 is 130. So 130 and 11.40. So that would be the length of that line. So I'll put 11.40. All right, so now that we have all of those, remember that perimeter is adding. So we would add 9, which is the length of BC, plus 11.40, plus what's our final number, 9.22. And one more time, type that into Desmos. So 9 plus 11.40 plus 9.22. That gives us 29.62 units. And that would be our answer. All right, so that's how we find the perimeter. The next thing we're going to do is we're going to find our area. So if you recall, the area of a triangle is your base times height, and you divide it by 2. So in this case, it's kind of hard to see what our base is because our base is usually flat. So if you actually turn your head, this counts as your base. So our base would actually be 9 because this is the bottom. So to find our area, it would be 9 times our height, and we're going to divide that by 2. So your height is slanted. If you remember from class, we can't have a slanted height. But if you look at the very top, which we call the apex, this is how tall it is. So to find the height, just use this number. Create a height on the inside, in this case. So in this case, our height would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be 9 times 9. All right, so when we start to do our math, that's 81 over 2, and that's going to give us 40.5 square units. That's the amount of space that's taken up within this triangle on this coordinate plane. And if you wanted to count, you could try to estimate it, but it'd be something around this.